Our today's topic is gravitation and universal law of gravitation. Before we start to learn what is gravitation, let me ask you some questions. Do you know how planets revolve around the sun, or how moon revolve around the earth, or if we drop an object at some height, why it falls towards earth? If you know the answer, then how come you know? First of all, let me remind you that to start a motion in a stationary object, or to change the speed of a moving object, or to change the direction of motion of an object, an external unbalanced force is required. Now let's start the beautiful story of Newton, which gave us the answer of all above asked questions. Newton once was sitting near the window of his room and was looking outside, and he noticed that an apple falls from the tree. Then a question came in his mind that why did apple fall straight towards earth? Why did not it fly away? Similarly, if we jump or throw some object in upward direction, why this object comes back towards earth? Why cannot we fly instead of coming back towards earth? As we know that to initiate a motion in a stationary object or to change the direction of motion, an external unbalanced force is required. So the first guess that comes in the mind of Newton was that there must be some force exerted by earth that pulls an apple towards it. Also, since all planets revolve around the sun in a circular orbit where their direction of motion changes continuously, the change in direction of motion must be due to an unbalanced force exerted by sun on each planet. Similarly, in case of moon revolving around earth, there must be an unbalanced force exerted by earth on moon that enables the moon to change its direction of motion. Then Newton came to the conclusion that nature of forces involved in all the three cases must be same, and he named the force as gravitational force. Let's try to understand with an example. Let's take a small piece of stone, tie it to one end of string and hold the other end of a string with your hand and move it around yourself. The stone will move in a circular path with a certain velocity, and its direction of motion changes continuously. The external force that causes the change in direction of motion is provided by your hand, as the one end of string is held by you. So the force which causes the change in direction of motion of stone is acting towards the center of circular path and is called as centripetal force, that is center seeking force. Here the center seeking force is provided by your hand. Based on this activity, we perceive that motion of a moon around the earth is due to centripetal force provided by force of attraction of earth on moon. Similarly, all planets of our solar system revolve around the sun due to centripetal force provided by force of attraction of sun on each planet. Now, if we release the string, the stone will fly off along the tangent to the circular path at that instant. Do you know why? This is because the moment the string is released, centripetal force is no longer provided and the stone is free to fly off. In the same way, if there would not have been any force of attraction provided by Earth on Moon or by Sun on all planets revolving it, The moon would have never been revolving around Earth, or the planets would have never been orbiting around sun. After deep observations, Newton came to the conclusion that every object in the universe attracts every other object by the force which he named as gravitational force and the phenomenon as gravitation. So we define gravitation is the phenomenon of attraction between two objects in the universe, and the force with which they attract each other is called a gravitational force. The objects may be on Earth or in space. They may be of any size, shape, or mass. They may be at any distance from each other, having any medium between them. We can also say the force of gravitation is always attractive and mutual. Now the question is, what is the law that governs the gravitational force? Since the gravitational force is mutual and attractive, and if we drop an object from certain height, it goes straight down to Earth. Why is not Earth moving towards the object? Also, since the force is attractive, why is not Moon falling into the Earth? Or why is not Earth and other planets falling into Sun? We will discuss all these questions, and let us start with the first one, that is the law that governs the force of gravitation. Newton declared that gravitational force between any two objects in the whole universe must be governed by same law, and put forward a law which is named as Newton's universal law of gravitation. The statement of which is as every object in the universe attracts every other object with a force which is directly proportional to the product of their masses, inversely proportional to the square of distance between them. The direction of force is along the line joining the center of two objects. Let us take two objects of mass m1 and m2 separated by distance r. If F is the gravitational force between them, then according to Newton's universal law of gravitation, the force F is directly proportional to the product of their masses. That is, F is directly proportional to m1 multiplied by m2. And the force between them is inversely proportional to the square of distance between them. That is, this. Combining the two equations, we have F is proportional to m1 m2 upon r square. To remove the sign of proportionality, we insert a constant g, and we get the final equation as F is equal to g m1 m2 upon r square. The constant g is called the universal constant of gravitation. The above equation is the mathematical expression of Newton's law of gravitation. This formula reveals some beautiful results, like if the product of masses m1 m2 is large, then force is also large. If we double the distance between the two masses, then the force becomes one-fourth of the original force. And if we reduce the distance between them to half, the force becomes 4 times the original force. Now let us try to find the unit and value of G. Since gravitational force is equal to G m1 m2 upon r square, on further solving we get G as this. As the SI unit of force is Newton and that of distance is meter and SI unit of mass is kilogram, so the SI unit of G is Newton meter square per kg square. Now if we put m1 and m2 equal to 1 kg and distance equal to 1 meter, then G becomes F as this. Hence, G is numerically equal to the gravitational force of attraction between two bodies, each of unit mass and kept at unit distance from each other. The accepted value of G was found by using a sensitive balance and is equal to 6.67 into 10 to the power minus 7 Newton meter square per kg square. The value of G does not depend upon masses of two bodies, distance between them, nature of medium, shape, size, nature of bodies, or anything. That is why G is called as universal gravitational constant. Now earlier we said if we double the distance between bodies, the force becomes 1/4. Let's try to find. Since force is G m1 m2 upon r square, let us make the distance twice, that is new distance r dash is equal to 2r. Therefore the new force is equal to F by 4, that is 1/4 of original force. Now if we reduce the distance to half, the new distance becomes r upon 2 and the new force becomes 4 times original force, that is F dash equal to 4F. One more question we asked was, if we drop an object at some height, it goes down straight to Earth. Why is not Earth moving towards the object? The force of gravitation is mutual, but since the mass of Earth is much more greater than the mass of an object, that is why the object is not able to pull the Earth towards itself, but the Earth is able to pull every object towards itself. So it is because of heavy mass of Earth that Earth pulls every object towards itself. Now the question is, if we kept two objects of same mass on the table, then why don't they collide with each other? Yet the mass is same. Actually, the gravitational force of Earth on these objects is much more larger than the gravitational force between them. The mutual force between them does not overcome the gravitational force of Earth. That is why they do not collide with each other. One more question was that why is not moon falling into the earth, or why is not earth or other planets falling into sun? Since as soon as earth exerts a centripetal force on the moon due to gravitational force, there exists a fictitious force called centrifugal force, which is equal in magnitude but acts opposite to the centripetal force. It is this centrifugal force which prevents moon from falling to the earth. This was all about gravitation and universal law of gravitation. Hope you understand the concept of gravitation and universal law of gravitation.